All right, so this next video is going to be working through a variety of problems. I'm going to be powering through them pretty quickly for the video's sake, but if you need to rewind, go ahead or pause it and try it on your own and then compare your answer. If you did not watch the previous video on the product rule, quotient rule, chain rule, and your transcendental derivatives, I suggest you go do that. And also, before you do this video, if you are uncomfortable with those rules, I would go back and we'll rewatch it as well again, okay? But before we jump into these examples, we need a review of our log properties. So the first one is the product rule, which is the natural log of x times y, okay? If you think back to Algebra 2 and in pre-calculus, we can expand this and rewrite it as natural log of x plus natural log of y. For the quotient rule, we'll have natural log of x divided by y, which we can expand that as well. Again, it aligns with the product rule, but you just change the sign in between. So natural log of x minus natural log of y. And then we have our power rule, which is natural log of x to the power of n. Bring the exponent to the front, we get n times the natural log of x, such that n is a constant. And I wanted to do a quick review of this before we jump into these examples because these do align with how the product rule, quotient rule, and chain rule work for calculus. All right, so you've known about these rules for a while, just not in the context of calculus. So if you ever get confused, kind of think back to your product rule, quotient rule, and power rule that you learned for logs when you were back in Algebra 2, okay? All right, so again, I'm going to power through these pretty quickly, but feel free to pause the video, and if you have any questions, just email me. All right, so we want to differentiate each function. We have y equals e to the power of 3x plus sine of 5x plus natural log of 9x plus 1. All right, so we're jumping right into it for number 1, it looks like. So e to the power of 3x, this immediately is going to be a chain rule. Okay, we have a composition function. So this is technically f of g of x, where f is e and g of x is 3x. So if we think about this, f of x, that will be our e to the x, and then g of x is 3x. That's our inner function, okay? So when I differentiate this, I think about the lollipop scenario or the Russian doll scenario. I'm going to take the derivative of the outer function, which leaves the inner function, and then I will take the derivative of the inner function. So f prime of g, the derivative of e to the x is e to the x, so that's going to stay the same. So the base will stay e. And then we have our g, which is going to be 3x. So nothing changes. However, we will multiply with the derivative of g. So g prime of x, the derivative of g is going to be 3. So we end up with 3e to the 3x, to the power of 3x. So if I'm taking the derivative of y with respect to x, my first term is going to be 3e to the power of 3x plus, we have another chain rule, okay? We have a composition function. So differentiate the outside first. The derivative of sine is going to be cosine. I already took one derivative, so my 5x stays the same. Now I'll take the derivative of the inner function. The derivative of 5x is going to be 5. All right, next we have natural log of 9x plus 1. Again, we have another composition function. So if you think back to natural log, the derivative is u prime over u, such that u is the interior function, okay? So 9x plus 1 is the u. The derivative of 9x plus 1 will be 9. And then the function itself is just 9x plus 1. Okay, so that is dy dx. All right, number 2, we have a composition function. So I will rewrite this as tan of x to the power of 8. Okay, this way I can clearly use the power rule, and then I'll also use the chain rule for this one. Okay, so the derivative of y with respect to x, we will bring the 8 to the front. When you use the power rule, that is differentiation. You use one differentiation rule at a time, okay? So I have 8 times tan of x, and then that's going to be to the power of 7, okay? Now I will multiply with the derivative of the inner function. The inner function is tan of x. The derivative of tan x, if I think back, tan x's partner is going to be secant. So it's going to be secant squared x. So again, for this one, chain rule, we have f prime of g times g prime. All right, number 3 is y equals x divided by cosine of x. So you can technically use the product rule or the quotient rule. However, if you use the quotient rule, you end up with that negative power, and that brings a whole host of problems on its own. So remembering the quotient rule is going to be important for you. So it's f prime of g minus fg prime over g squared. In this case, your x is f, and then cosine is g. So the derivative of y with respect to x, f prime, the derivative of f, is going to be 1, times g is cosine. Minus, we have f, which is x, times g prime, the derivative of cosine, it's a co-function, therefore the derivative is going to be negative. So negative sine x. And cosine's partner is sine. All over g squared, that's going to be cosine squared. You don't have to simplify this. However, if this was a multiple choice problem, it would not be in this form. So it is good to practice simplification in the unit, but on your assessments, if it's a free response, you don't have to simplify. You can save seconds, which add up to minutes, which gives you more time to work out more difficult problems, okay? So we have cosine of x plus x sine of x over cosine squared x. All right, number 4, f of x is equal to the cubed root of 5x squared plus 6x. So this would be a quick rewrite. So 5x squared plus 6x to the power of 1/3. This is so that we can effectively use the power rule. And then again, we have a composition function, so we will also have to use the chain rule, okay? So f prime of x, using the power rule, I bring down the 1/3, 5x squared. Now, before I write this, when you bring that power down, do not change the inner function, all right? Using the power rule is a differentiation property, all right, or a differentiation rule. You use one rule at a time, okay? So once I bring that power down, don't change the inner function. It still stays the same. So 5x squared plus 6x. And then 1/3 minus 1, we get negative 2/3. Now we're going to multiply with the derivative of the inner function, which we can use the power rule again. Don't need that. So we have 10x plus 6. Now again, practice simplifying, okay? In the numerator, we will have 10x plus 6. The denominator, we have the 3. And then this is negative 2 over 3. So that negative means it goes in the denominator. 2 is the power, and then 3 is the root. So it's going to be the cubed root of 5x squared plus 6x squared. Again, if this was multiple choice, you would see it written in that final form there, okay? All right, number 5, y equals the natural log of 3x plus 1 divided by 5x minus 1. So don't always go straight into differentiation. Get a good rewrite so that you have to do, the least work possible, all right? Using calculus is about being efficient. So don't jump into using the quotient rule, especially since you have a rule from Algebra 2 that you can use that can expand this, okay? So we have y is equal to natural log of 3x plus 1. It's dividing, so we'll do minus natural log of 5x minus 1. So now instead of using the chain rule and the quotient rule, I just have to use the chain rule as far as logarithmic functions. So when I differentiate this with respect to x, the derivative of natural log is going to be u prime over u being the function inside the natural log, okay? So the derivative of 3x plus 1 is 3, and then u itself is just 3x plus 1. And then we'll do the same for the second term. The derivative of 5x minus 1 is 5, and then the function itself is 5x minus 1. Now, if you chose to do the chain rule and the quotient rule, and you got the correct answer, you'll get credit for it, but efficiency is key in this course. All right, a of t is equal to pi times r of t squared. Okay, so we are taking the derivative of the area with respect to time. That's kind of how I'm reading this. Okay, and then the r could be the radius. Okay, so the derivative of a with respect to t. Pi is a constant, so that's just going to float around. All right, so we're going to use the power rule for this. So I'll bring down the 2, nothing else changes. Okay, so I have 2 pi times r of t, and that's going to be the power of 1, so we'll leave that alone. But now we have the chain rule. We have a composition function. We're going to multiply this and take the derivative of r with respect to t. So the derivative of r with respect to t. So on the front here, looking at that chain rule, we have f prime of g times g prime. In this case, the f is the outer function, which is the squared, that 2, that power. G is r of t, that's the inner function. All right, number 7. G of x is equal to x to the 5th plus x to the 4th plus x cubed divided by x. Okay. Again, you could use the quotient rule, you could use the power rule, but since we have a single term in the denominator, just split them up. So we have x to the 5th over x plus x to the 4th over x plus x cubed over x. And now we just have to use the power rule instead of taking up time to use the quotient rule or the product rule. Okay, so when we reduce this, we have x to the 4th plus x cubed plus x squared. So g prime of x is equal to 4x cubed plus 3x squared plus 2x, such that x cannot equal 0 because in the original form it was in the denominator. Do you have to include that for full points? No, but it is good to understand. And I want to reiterate, if you use a different rule and get the correct answer, you will still receive full credit, okay? All right, number 8, y is equal to secant of x squared plus x. So we have another composition function, so we will have to use the chain rule. The derivative of y with respect to x. So this one's interesting. The derivative of secant x is secant x tan x. So the derivative of secant x is itself and its partner, which is tangent. That's the same as cosecant x, which is itself and its partner cotangent, but it's negative because they are co-functions. Now think about this. Our input is x squared plus x. We end up with 2 inputs in our derivative. Therefore, those inputs should align with the original input. So we end up with secant of x squared plus x times tangent of x squared plus x. And since it's the chain rule, because we have a composition, we will multiply with the derivative of the inner function, which is 2x plus 1. So that's the derivative. And the chain rule again, we end up with f prime of g times g prime. Same pattern every single time for chain rule. Number 9, we have h of x is equal to x to the power of 8 times cosine of x. So I think this is the first product rule that we have, which that's crazy. This probably should have been the first one, but so product rule, recall f prime times g plus fg prime, okay? So x to the power of 8 will be f, cosine will be g. So we'll have h prime of x. The derivative of x to the power of 8 is 8 times x to the power of 7. Again, you've taken a derivative. Each term gets one derivative, okay? So now we just leave g, which is cosine of x, plus f is x to the power of 8. And cosine's partner is sine, all right? But because cosine is a cofunction, it's going to be negative. And we can clean this up a bit. You are not required for free response. So we have 8x to the power of 7 cosine x minus x to the power of 8 sine x. All right, number 10, we have cotangent x divided by x squared. All right, so again, you can either use product rule or quotient rule for this. However, power rule, you will get that negative exponent. So we'll call cotangent x f, we'll call x squared g. And we have f prime g, f g prime. So remember, the numerator for the quotient rule is the same as the product rule. It's just a minus instead of a plus, and then we divide by g squared. All right, so it's already in a pretty good form to differentiate. So we'll do dy dx is equal to f prime. So cotangent's partner is going to be cosecant. So think of tangent. The derivative of tangent is secant squared. Tangent's cofunction is cotangent, so the derivative of cotangent will be cosecant squared, but it's negative because it's a cofunction. So we'll have negative cosecant squared x, and then g is just going to be x squared. And then minus f is cotangent x, and then g prime will be 2x. And this will be all over x squared squared. All right, if this was a free response, you could stop, but we're going to go ahead and work on simplifying. So we end up with negative x squared cosecant squared x minus 2x cotangent x divided by x to the power of 4. Every term has at least one x, so we can go ahead and cancel one of those out. So we end up with negative x cosecant squared x minus 2 cotangent x divided by x cubed. All right, number 11, we have f of x is equal to cosine of 7x to the 5th. So you don't have to rewrite it, but it is easier to see it to use the power rule. So we'll have cosine of 7x to the 5th. Now this is chain rule, but I think this is our first composition of 3 functions. So we're going to use the chain rule a little bit more than the other problems that we did. So this is taking the derivative with respect to x of f of g of h of x. Okay. So you don't have to rewrite this every single time, but it does help to see, okay, I have f, I have g, I have h. We are going to be using the chain rule 3 times. So if I were to expand this, that means I'll have f prime of g of h of x times, I took f prime, now I'll work my way into g prime of h of x. And then I worked my way in again, so now we'll go to h, which is h prime of x. So we're using the chain rule 3 times. All right, so let's try this. So we have f prime of x. The most outer function is going to be that power of 5. So I'm going to bring the 5 to the front, and then I will have cosine. The new power will be to the 4th, and then I have 7x. Next, I'm going to work my way in. It's going to be the cosine, okay, which is g technically. So we'll have times. I will have, now, let me rewrite this just so that we can be consistent for now. This is 5 times cosine of 7x to the power of 4, okay? Whoops, that should be a times. You will have to get comfortable with that superscript being after the cosine, but for now, since we're learning, I'll keep it on the outside. Now, we already did the power rule, so we ignore the 5 and the 4 for the next step in the chain rule. I only want to focus on the cosine. The derivative of cosine is negative sine. So I'll have negative sine and I already took a derivative, so the 7x will stay the same. Okay, again, you take one derivative at a time. So now the last part is I want to focus on the 7x, the next interior function. The derivative of 7x is going to be 7. So if we clean this up, we have a 5, a negative, and a 7 that are on the outside, that are not part of the transcendental functions. So I'll have negative 35, and then I have cosine to the power of 4 with an input of 7x, and then the last one will be sine of 7x. All right, the last problem for this video is we have y is equal to the sine of the square root of x. So we can do another rewrite for this. So we have sine of x to the power of 1/2. Some misconceptions, people try to bring the 1/2 to the front. You cannot do that. That is specific to natural log. Also, whatever is happening inside for a transcendental function cannot be taken out, all right? That is a function of its own that is being evaluated using sine, cosine, or any other trig. So there's no property that allows you to pull that 1/2 or factor it out or anything. Everything that's happening inside of there stays inside of the trig, okay? So y prime. So this is chain rule. The outer function is sine. The derivative of sine is going to be cosine. So I took a derivative, so now leave the square root. But now we will take the derivative of the inner function, which is x to the power of 1/2. So we'll do 1/2 with x to the power of negative 1/2. Cleaning this up, cosine the square root of x will be in the numerator. We have our 2 in the denominator, and then the square root of x in the denominator. Again, I see this every year. This square root of x is part of cosine x. You cannot cancel these out, and then it just becomes like, that does not work. It does not happen, okay? And that's another reason why I say don't simplify, which you should know that. You should know that the square root of x cannot be canceled out, but it still happens. But if it was a multiple choice, you would see it in this form, okay? All right, 13 through 24 will be in the next video.